All right, section 7.3 is similar right triangles. And in this picture, as you can see what we have, we started with a right triangle. That's the huge triangle. And when we draw the altitude to the right triangle, what happens is we get three triangles, and all of them are similar by angle-angle similarity. And because they're all similar by angle-angle similarity, they have sides in proportion. Okay, so one of the ways to take a look at this is each of these triangles is similar, so we can draw them with their parts aligned. And you'll see that the huge triangle, ABC, when we line it up with the hypotenuse down in the lower left corner, it matches up with the medium triangle, where B and B are the same, D is the same as C, and then A is the same as C. And then we have the smallest triangle, the parts that line up, the C lines up with the B of the big triangle. The D lines up with the C of the big triangle. And the A lines up with the A of the big triangle. So what we have, and I'm just taking the red letters are taken right from the drawing above. We could see that the parts that line up here now, the hypotenuse of the large triangle is m plus n. That lines up or is similar to, proportional to the A of the medium triangle and the B of the small triangle. Talking about these parts here. All right, this is the hypotenuse of the large triangle. This is the hypotenuse of the medium triangle. This is the hypotenuse of the small triangle. So when we write our similar proportions, those will be in the same spot in the proportion. All right, so if we want to compare the medium triangle to the small triangle, the medium triangle to the small triangle, the M is the long side of the medium triangle. The H is the short side of the medium triangle. The long side of the small triangle is the H, and the short side of the medium triangle is the N. Now the reason that this is important is, as we write these proportions, we have to put the parts in the same order. So we're going long length over short length for the medium triangle, and long length over short length for the small triangle. You'll notice that the H is the geometric mean. The H goes in the geometric mean. That is the shared side. So as I'm going through and doing these problems, that's where I start. I always ask myself the question, what is the shared side? And then I'm going to put it in the geometric mean. Okay, here's a typical problem from section 7.3. We're going to do number 6. And we're asked to solve for K. Now, the way I go about solving this problem is the first thing I do is I look at it and I say, okay, which is the shared side? Of the information that they give me, I ask which is the shared side. Is it the K, is it the 21, or is it the 10? Well, it is the 10. The 10 is the shared side. It's being shared by the smallest triangle and the largest triangle. The 10 is being shared by the small triangle and the large triangle. The shared side is always the geometric mean. So I'm going to put the 10 here and there. That's where the geometric mean goes. So now I ask myself the question, what is the 10 for the small triangle? The 10 is the hypotenuse for the small triangle. And that means the hypotenuse for the large triangle has to go in the denominator over here, because they're similar triangles, their sides are in proportion. And the hypotenuse of the large triangle is K plus 21. So K plus 21 is the hypotenuse of the large triangle. What is the 10 for the large triangle? Well, it is the shortest side of the large triangle. So then we have to ask ourselves the question, what's the short side of the small triangle? That's K. So that's our proportion. We have K over 10 equals 10 over k plus 21. Now at this point, in order to solve for k, we've got to be able to solve the proportion. And I'll leave that for you.